Okay, thank you. So, well, my talk is not related at all with cosmology or even with computational, but I don't know why I'm here. So I'm going to talk about the origin of the solar system from the study of chondritic meteorites. Probably you don't know what chondritic meteorites mean, but you know what meteorites are, you know that meteorites are cool. And if you don't agree with that meteorites are cool, let me just remind you the meteorite that fell in Russia last year, which was really incredible. So, well, but who we are? We are the group of meteorites, minor bodies, and planetary science group at the Institute de Ciencias de la SPY. And we are a group, a multidisciplinary group that use several different point of views to study meteorites, asteroids, and comets. And we use three different ways to study these objects. First of all, we use the telescope at the Observatory Astronomic del Montsec that allow us to follow asteroids and comets and obtain their trajectories and see where they go, where they come from. We also use the Spanish Meteor Network to follow the trajectories of the bodies that enter our atmosphere, and then we can know where they fall and also where they come from. And last of all, we study samples in the laboratory that allow us to know also where they come from and what the meteorites are made of. But I was supposed to talk about chondritic meteorites. Well, chondritic meteorites are meteorites which are formed in the solar system. I mean, they are formed with the most primitive materials of the solar system, with dust, but also with what we call chondrules, which are these kind of spheres you can see at the bottom of the slide. And this material is formed, well, just in the first million years of the solar system, they aggregate, so they form what we call the planetesimals, and after that they form what we call the planetary embryos, which are the beginning of planets. So, studying these materials, we can have information from the beginning of the solar system. But as I said before, we study these objects from three different points of views. First of all, we use the telescopic Moyano Observatory Astronomic del Montsec. And with this telescope, we can obtain the orbits and see the trajectories of asteroids and comets, and what we call the potentially hazardous objects, which are the asteroids and comets that, for their size and also for the probability of colliding with our planet, can eventually become dangerous for us. So it's quite interesting to follow them to know if we are going to die or not. Also, we can obtain some information about the properties of these bodies, also the orbit, but also the density, the mass, and other things that allow us to know what they are made of, more or less, and allowing to relate them with meteorites. We also use, as I said before, the Spanish Meteor Network. That is a network of cameras around all Spain that allow us to see when a meteorite falls in our country or close to our country. We can follow just the trajectory of this body, and then we can know, which is more or less, we can calculate its orbit, and we can know where it falls, or we can more or less see the stream field, which is the area where we suppose that the meteorite has fallen. But it can be a really large area of several kilometers square. But we can go to the area and try to search for pieces of the meteorite. Once we have the meteorite, but not only the meteorites we find, we also work with meteorites from several places, also from NASA and other places. We can study these meteorites in the laboratory using different techniques, spectrography, microscopes, and so on. And we can see the mineralogy of these objects, we can study different properties, so we can relate them with the asteroids we know and also with different comets. And this allows us to have the opportunity to study several interesting objects, like for example the meteorite that fell in Russia, as I saw before, which is the Chelyabinsk meteorite, you can see at the bottom of the image. But also we study meteorites coming from different planets, like the one at the top, which is a meteorite from Mars. And it's the first meteorite. When it was studied, some people say that they have found proofs of life on Mars. But after several studies, it was proved that probably this is not it was not proof enough of life on Mars. But anyway, it was quite interesting. And well, as you can see, the scientific community is really interested in asteroids. There are several missions going to asteroids just to collect some pieces of the material and bring them back to Earth to study them and compare them with meteorites. And well, I have just a final question. Are you interested in meteorites and all that after the talk? So if this is so, congratulations, because we are searching for people to work with meteorites, and we are interested in the people working in different fields, because we need also chemistry, physicists, and all kinds of people working in this field. So if you are interested, just let me know, leave your work and come to work with us. Thank you so much.